Awesome. All right, I think we can get started here. Thanks everybody for coming. Welcome to our presentation. My name is Kevin Roy. I run product marketing over here at Orkes. I'll be kind of the moderator for this session. We've got a great presentation for you guys today. We've got our CTO and co-founder Viren here, as well as Ray Strickland from Amazon AWS to help us out. I'll let them introduce themselves, and then we'll go over a bit of an agenda, and then we can jump right into it. Just to note as well, we will have a Q&A session towards the end of the presentation. If you do have any questions, feel free to submit them with the Q&A tab within kind of the bottom or top of your screen on the control bar there, and we will try and get to as many of them as we can, time permitting towards the end. So with that being said, I will let these guys introduce themselves and get things kicked off.
Sounds good. Thanks, Kevin. Hi, everyone. Thanks for kind of joining in this presentation. My name is Viren. I'm one of the co-founders and a CTO here at Orkes. And I will let Ray introduce himself.
Hello, I'm Ray Strickland with AWS. I'm a senior partner solution architect on the data AI ML team, and I focus on enabling our partners on Gen AI.
Awesome. Thanks, guys. Appreciate that. So just for the agenda for everybody that's here, we've already done the introductions part, which is great. So we'll go through some challenges around the AI LLM application creation space. We'll get into Bedrock and AWS, why production is harder than getting into a proof of concept, which is kind of the nexus of this meeting or this webinar itself. Why Orkes and AWS just works from a partnership standpoint. Some examples of some of the applications we'll be talking through today, and then we'll go through some quick closing thoughts and questions. So with that being said, we can jump right into it.
Right. All right. So to start with, right, as kind of we are talking about, why is it that, moving from POC to production is harder with, generative AI applications. So let's kind of start the discussion talking about the state of the world, where things are today. So when we look at generative AI and when it comes to frameworks, I would say there are two categories of, frameworks and support that we have, right, and platforms. So you have foundational models. Some of them are open source like Mistral or, Llama and so forth. And then there are models from OpenAI, and then cloud specific kind of models from AWS and Google and all. And then to work with those models, you have kind of frameworks like, Llama Index, for example, LangChain, that allows you to work with language models, allows you to kind of tap into the ecosystem of different libraries for, working with data and all. So, what then it kind of boils down to is that, like, if you want to build out a proof of concept, it becomes very easy, because you have all the necessary frameworks and platform available to it. And LLMs have become quite widespread, right? It used to be the case where, like, language models were in the domains of large tech companies only, but now it's pretty easy for anybody to start, getting an API key and start working with it. So that's the current state of the world. Now, if you kind of move on from there, if you go to the next slide, it's easy to kind of, build out a proof of concept application, right? So let's say here is a kind of a simple application snippet that allows me to kind of index a document into a vector DB and test it out, right? That, okay, yeah, looks good, it works. But then the big question comes is that, like, how do you run this in production? So, like, let's say my POC works, things look good. I want to run this in production, roll it out to all of the user base in my company. How do I do that? And more importantly, where do you actually run this code base? Like, is there a runtime available for this that I can, tap into and start using it? And we'll dive deeper into, why that really matters and where they are. I'll hand over to Ray to talk a little bit more about Bedrock and AWS here.
Thanks, Vern. Yeah, so last year, as things started ramping up for AWS with Gen AI, and looking at these challenges, in response to that, AWS announced the release of Bedrock. And Bedrock's a new foundation model platform that designs, and we go to the next slide, please. The new foundation model platform, and that's designed to provide developers with a suite of pre-trained models, APIs, and tools that make it simpler and more cost-effective to integrate Gen AI capabilities into their applications. And Bedrock is by far the easiest way for our customers to create generative AI-based applications using foundation models. And because Bedrock is a fully managed service, customers can get started quickly with a range of foundation models, securely and privately customize them in their own with their own data, and deploy those models into their applications without the need for managing the infrastructure. And we're also very excited. Bedrock is the only service to offer foundation models from Anthropic, like the recent cloud Haiku, Sonnet, and of course Opus, as well as models from Stability AI, and of course our own Amazon Titan models. So Bedrock ensures that any customization remains private for each AWS organization. And these services include our known security capabilities like private link, IAM access controls, and of course, KMS encryption as well. For responsible AI, all of our third-party model providers take this topic very seriously. Amazon's own Titan models will detect and remove harmful content within the data, reject inappropriate content in the user's input, as well as filtering the model's output that might contain inappropriate content, such as hate speech, profanity, and violence. And we're really just getting started. As Bedrock continues to mature, we've added tools for things such as model evaluation. We have added, we'll talk a little bit about knowledge base that allows you to easily configure a RAG solution with a simple wizard interface. And recently, we've made available agents which allow AWS to manage many of the ML ops orchestrations for you, and easy integration of third-party tools like Orkes here. Thanks for that.
All right. So thanks, Ray. Like diving deeper into kind of generative AI and some of the opportunities, right? Like why we are all even here, right? Like, and if you think about it, right, like, there have been kind of, initial kind of adoption when it comes to, one of the areas where generative AI really helps enterprises is kind of making sense of unstructured data. We all are sitting on a mound of data that is completely unstructured, and trying to make sense out of it, try to kind of create a business impact out of that. I think that was like early use cases, and that still continues to be the case. Second area where we see opportunities when it comes to generative AI for enterprises is how do you upscale the productivity for the workforce? Essentially, build very powerful co-pilots, enable humans to kind of operate at 10x in terms of their capabilities, and really drive the business value. But more importantly, beyond those two things, where it really drives the message home is, how you can leverage generative AI to create new opportunities for the businesses, right? In terms of the use cases that were not possible earlier, or some of the services that enterprises could offer that were either not feasible or not possible, now those are the things that have suddenly become kind of available and in the realm of possibilities. And this is why where we see a lot of initiatives, a lot of POCs being done to kind of see where can we drive the innovation when it comes to generative AI. So if we kind of go to the next slide, and when you start kind of tinkering and starting to kind of use generative AI, like let's look at the lifecycle of a generative AI application. And really there are two parts to it, right? There is one, the entire application development process, right? Like you have a set of data that is available to you. So like, identifying the data, figuring out which model to use. And again, like, you have a plethora of models available, and, not every model is suited to do, every possible task, and sometimes the models might be an overkill both in terms of the cost as well as the latency perspective. So figuring out which model will work with your data to achieve a particular use case. If required, you want to probably fine-tune a model so it can operate a lot more quicker in terms of latencies, reducing the context window length and things like that. You want to index your data once you identified, and where, and kind of central to all of these things is the prompt engineering, right? A completely new discipline that is kind of starting to evolve now. But now, comes the next part, which is basically runtime operations. Once you have built the application, you have to essentially integrate this with your existing applications. As we all know, no application is an island. They are all interconnected in one way or other, either through APIs, through data, through events, and so forth. So, you have the next step, which is basically how do you integrate what you have built with your existing set of applications, where do you deploy? And more importantly, once you have deployed, there comes the entire LLM ops, right? You are monitoring for multiple things. One is, how your application is doing. In the end, Gen AI applications are inherently stochastic. So, continuously monitoring them for their kind of accuracy becomes important. Also, these are also potentially very expensive infrastructure to run. So understanding, where you are using it, what's the usage pattern and things like that. So there is this entire kind of discipline around LLM ops and monitoring those things that comes into picture. Moving on to the next slide. Let's say you kind of address those things, but then comes the next set of it, which is less a technical part of it and more in terms of before you go to production, things that you have to kind of take into account, right? And some of these things are kind of new to generative AI application that did not have to worry about when it comes to traditional application development, right? And some of it we already had things in place, you have to have right level of compliance. If you are using more of a machine learning process to kind of generate responses, how are you auditing those requests and responses? So when it comes to it, you have the right level of auditing available that you can use it for your compliance perspective. The safety and governance is another part of it, and it essentially falls into two categories, right? So one is that if you are leveraging a hosted model, and for a model to kind of work, you are essentially giving the context, which might and potentially is sending your enterprise sensitive proprietary data to it. How are you ensuring that which data goes in there, who's able to ask questions on that data, and more importantly, is this data going to be shared and reused? The whole aspect around the private model hosting and things like that. The other piece is, how are you able to kind of reuse those things? We are not there yet where we can say that the language models will make all the decisions and do everything, right? There is the aspect of safety, which also involves adding humans to the loop. So what is that model looks like? How are you going to be able to add humans to the loop? Are you sending every request to a human to do a review, or you are only sending some requests? What does that algorithm look like, and how are you kind of doing that? I think that is important. And other piece there is, one is this entire space is evolving at a very rapid pace, right? In some ways, or in many ways, as compared to other enterprise technologies, this is one area where the pace of innovation has kind of has been accelerated quite a bit, which also means that you have to constantly keep up to date. And if you don't do that, you are either potentially missing out on some of the things in terms of the features or the cost and other optimizations, right? And last but not least is, if you have invested significant amount of time in terms of building out your engineering and development practices, how are you able to kind of get everyone to be able to use generative AI to kind of add it to the applications without necessarily having to invest the amount of time and resources on training existing developers, essentially reducing the friction so that everybody can use generative AI in a safe, compliant way, without necessarily having to worry about things and inventing kind of new processes and retraining the workforce. So again, just to summarize, right? Like when we look at the current state of the generative AI tooling and the platforms, pretty easy to do POC. If you ask today, anyone, hey, let's try it out a new agentic workflow, or we want to build a RAG-based application. There are many models available, decent amount of frameworks, easy to kind of build out a POC. Most of them tends to be very Python heavy, given the nature of the system and its roots in the data science community. A lot of frameworks are still very Python heavy. So if you are using, for example, C# or Java, you might have to figure out a way to do that. But where we see kind of lag is when it comes to the platforms to run safely your kind of applications. One part where, for example, AWS innovates and with Bedrock helps out is the platform to kind of run foundational models, right, in a safety compliant way. But that's one part of it. The second part of it is like, where do you run your applications, right? So that's basically where the gap is, and I want to talk a little bit more about it in the next few slides. So let's dive deeper into when you are building generative AI based applications and you have an existing architecture, how do they fit into that? What does that runtime look like? So if we want to put together a use case or a set of guidelines for what kind of that platform looks like, one topmost thing, the way we think about it is, how does it coexisting with the existing application infrastructure? Again, going back to the point that no application is an island. Like they have to work together to achieve the business goals. So that becomes very critical for them to be able to integrate with existing set of your investments, right? Your microservices, your eventing systems, everything that you have in place. Other piece is language models are very asynchronous. So the communication has to be asynchronous. How do you kind of enable that? I will not go detailed into prompt management. I think enough has been said about this. Then the other piece is you are indexing all of your data into vector DBs. Essentially, now you have to start thinking about some sort of role-based access control, right? Very similar to how you would have done for your data that is sitting into relational databases or a MongoDB or some NoSQL. But now, instead of very well-defined queries, these queries can be very arbitrary, potentially generated by AI. How do you kind of enable those things? And last but not least is handling infrastructure level kind of concerns around caching the responses, maybe doing semantic caching, and not at the process level, but rather across multiple processes, right? So in a distributed environment, you have to be able to handle those things. The platform also has to give you ability to kind of add humans in the loop, either through well-defined rules or through some sort of heuristics, but critical to kind of add humans in the loop. And when we talk about humans in the loop, right, it now takes a different shape, right, in terms of what does that mean? It could be that humans are reviewing all the responses. It could be that humans are asynchronously reviewing the responses and adjusting the prompts, or putting some guidelines in place, or based on some rules and heuristics. Sometimes humans are in the loop, other times they are not. And last but not least, once you have all of these things addressed, does your platform allow you to scale your POC to production? Imagine you have thousands of users, or millions of users. If you are a consumer-based application, how does it kind of scale to this level of the volume? So let's dive a little bit deeper into some of the aspects, right? Think about integration with an existing application infrastructure. So you could have an application, a generative AI app that essentially maybe makes a call to a microservice, let's say, to get some user information, then using that information as the context with some prompt, makes a call to a generative AI foundational model to do a chat completion to generate the response. And maybe that response is sent back to an eventing system like Kafka, so that some system can process it. So now what you have done is, like, you have an application that talks to like 3 different systems in your enterprises, right, including a generative AI model. And if you go to the next slide, one thing to note here is that, like, depending upon which model you are using, what kind of infrastructure that you have available on that model, and also the amount, like the type of request that you are sending, this could take time. This could take, if not milliseconds, seconds. We have seen some of the models that can respond in milliseconds, but that may not be kind of appropriate for every task. That might be very cost prohibitive to use. So again, now we are talking about asynchronous communication. At any point of time, you could get rate limited by underlying system. You have to handle those things. So essentially, what you are trying to build is long-running durable flows, and your platform has to be able to kind of handle those things. The next aspect of that building applications is we talked about managing, governing, and reusing prompts. If you imagine, like, you have hundreds of applications, they are all hard coding, or if not hard coding, putting the prompts in their own applications. Now getting sense of, how many different types of prompts do I have in my organization? Which prompts are being kind of engineered to work with which model? And what happens if I change the model? So I give you a simple example, right? Let's say you have a prompt that you tested with GPT-4. GPT-4o comes, or let's say you are working with Anthropic, a good example, right? You start working with a Claude, and the prompt works very well. Now you look at Sonnet or Haiku, and they are faster, a lot more cost effective. You want to switch. Will your prompt work with it or not? And if you just switch it without really testing it out, you might be in for a surprise. Maybe the accuracy may not be as good as before. There might be a lot more hallucination. So it becomes important that, like, your prompts are not only governed but also kind of attached to a specific model, so that, like, before switching the models out, somebody has gone through right level of testing. And I believe AWS has the platform capabilities in terms of being able to evaluate models with your prompts. So you could use something like that before actually putting that into production. Then coming up to the next one, right, is security and access control. Yes, let's say you have integration with Bedrock, and you are able to use, say, Anthropic. You are able to use Mistral and Llama 3 and Titan models. Can everybody use that model? What if some of the models are expensive to use? Do you want everyone to start sending all the requests? How those requests are managed? Like, do you set up an internal proxy? That seems to be one of the very popular kind of way to do that. But, like, now your proxy has to keep up to date with all different types of models, manage the traffic, handle all the things that we talked about it. Does everybody has access to API keys? Like, what if I want to test locally on my laptop? How does that work? And more importantly, if I have indexed my data, let's say I'm working on financial data, right? Like, I want to index all my purchase orders or the invoices, and be able to ask questions on it, so that, like, my team that is my vendor management team is a lot more efficient. But can anybody send a request to that model or a database index? If not, like, where is that access control maintained? So security becomes paramount, I think. Yeah. And then going on to the next one, how do we improve the model response? If you are building applications where the humans are waiting, right? Like, one thing we all hate is waiting for things to happen, right? Also, can you catch some of the responses? So, like, the repeated query doesn't have to be sent to the model. You can probably do some sort of semantic caching, a caching based on certain parameters. Maybe the request to your application is not really a natural language, but rather a particular set of questions that you are translating, which means that caching is a lot more deterministic, right? What happens when you have retries that you need to put in place? And let's take an example, right? For example, say you have a vector database where you have ingested quite a bit of data, or you are using with a model with predefined throughput. You don't want to send more requests than what it can handle, and reduce the latent or increase the latencies for the application. So it becomes important that, like, you put some sort of rate limiting in place. And that could go, and rate limiting then kind of helps in two ways, right? Improving the responses for the model, because if you say that, like, I can only handle 100 requests per second, then 100 requests will be served, when more than that will get rejected. If you don't have rate limits, what's going to happen is that somebody sends 200 requests, everybody else is going to suffer, and then people will start to see higher latency. So some of the things you want the platform to take care of it for you. Then moving on to the next stage from here is, again, we talked about prompt safety and governance. So one is before you put a prompt in place, and also you don't want to kind of use the raw prompts in your application. Prompt templating has become a bit popular lately, but I think the bigger question there is that where is the inventory of all the prompts that you have, how they are associated with the different types of models, and when you want to change it, what is the process that is required for someone to test it out and certify that this prompt works well with, let's say, Anthropic Claude, or now this is also good to go with Mistral. One of the things is that based on either kind of preset rules, you want to probably put a human in the loop. So, when you send a request, maybe your prompt is engineered in such a way that, like, where it does not have enough confidence to give the answer, instead of kind of hallucinating, it is able to kind of generate a specific response that you can use it to put a human in the review loop. Or it could be optional, and maybe small percentage of traffic is always directed to the human, and then you are capturing the data to look at how many responses are coming out to be false positives, or has kind of not the right level of accuracy, and therefore you have to put in more efforts into fine-tuning things and whatever not. But I think that becomes critical in terms of not only one part of it, which is to manage the prompts, but also at runtime, right? How you are incorporating those things and how safely, and what happens when you have enough confidence and you want to remove the human from the loop. So that's critical part to your platform. So then let's dive deeper into, we talked about the nature of the platform for runtime. Ray talked a bit very briefly about, like, what kind of foundational models and how AWS helps with respect to Bedrock. So what does that mean for Orkes and Bedrock? So one thing that we do at Orkes is, as I mentioned, right, like Orkes is a platform for building distributed applications. And again, going back to reiterating the same point, right, that no application is an island, which means that you have to be able to work with a lot different set of integrations. So one thing that Orkes provides is in a full suite of integration with Bedrock, which means that if you want to build out application that uses the models from AWS Bedrock, you are able to kind of safely do that either through publicly available models or through private link. Basically, all the modalities that AWS offers, you are able to leverage that and build out your application. And not only that, your integrations could be different based on your environment, dev production. Maybe dev environment has a lower throughput configured, just like, you would not provision 8-core database for your dev environment. It might be a T3 medium, but your production might be a 2x large. So, same principle applies, and that lets you kind of do it very seamlessly. Other thing is that, with Bedrock, you can have private models, which means that you are not sharing your sensitive proprietary data with anybody else. You have your own model with very predictable provisioned throughput. And more importantly, you are able to use the right model for the right job. And we'll see that in a bit, right? Like, not every time you have to use the biggest possible model to solve the problem. Sometimes, smaller model just works fine. But that means that you should be able to kind of have access to multiple models and test it out, see what works, and use the right model for right team. So instead of saying that, like, everybody uses, let's say, Llama 7B for everything, which may not fit for every use case, you should be able to have a plethora of models that you have configured, and then based on the application use cases and what works the best, I should be able to go and choose which model works for me. But that means that now developers within the company has choices, and those are all safely governed in one place. So, you have a complete inventory of who is using what models, how they are used, and so forth. Going up to the next one, let's talk. So let's take an example. So take, for example, you are building an application to build a customer service agent, right? One way to think about it is, you'll use the biggest possible model. Let's say I'll use Anthropic Claude for doing everything. Is it really required to do that? Maybe my application model is slightly different, right? Like, what I'm going to do is that when a request comes, I want to first do some sort of intent detection as to what the user is trying to do. And based on that intent, and that means, like, now my kind of entire scope of what I'm asking the model to do is very much narrowed, right? I'm doing a very simple classification here, and more likely a simpler model might just do fine with that rather than having a large model, which also means that, my responses to the user can be much quicker. Like, I could potentially give back responses in milliseconds as opposed to seconds. And then I can use a larger model to generate the answers. Maybe based on the intent, I don't even have to call a model. I might be calling an API or things like that, or maybe I'm putting a human in the loop. Let's say if the request saying I want to talk to somebody, well, then you want to put a human in the loop, right? Rather than sending a request to the language model. And then of course you have vector databases for enabling knowledge bases and things like that. And again, as I mentioned, right, like you have microservices probably you have already in place that you want to kind of integrate with. Let's say if the customer sends you the order number, you probably have a microservice available that given order ID gives you order details. So, being able to call that and get the details and as a context to the model becomes important. And maybe you are implementing your business logic in Java, not in Python, because that's where your existing libraries and integrations and developer knowledge base exist. So a very simple example, but as you can see, a lot of integrations, a lot of complexities involved, and we have not even talked about how do you run this in the production. So now if you go to the next one, this is where essentially, conductor helps. If I were to build this similar application using Orkes conductor, then essentially what I'm doing is, I am leveraging something like a Bedrock for all my model capabilities in terms of integration. I would have an integration with a smaller model for intent detection, larger model for generating the responses, Orkes and we'll leverage conductor for integrations with eventing systems, API calls, and so forth. And one thing that where conductor kind of fits very well is like it allows you to then put right level of access control. It allows me to audit all my requests. So I could have a task at the beginning of the workflow to capture the request and put it into a database for audit logging purpose. So later on I can run some sort of reports on that one and things like that. And more importantly, now when it comes to implementing business logic, so sticking to our customer service chatbot example, let's say customer wants to reprioritize the order or change the delivery address. Now maybe that requires a specific business logic to be implemented in terms of it might have to reroute the request, update database, and ET and all of those things. Then maybe the entire process and the function is written in Java. And maybe that's an existing system available, right? Orkes allows you to kind of do this very seamlessly without having to kind of reinvent these things. Or you are also able to use things like LangChain, for example. Let's say I want to kind of extract data and parse a PDF file and do more stuff on it. And LangChain has, and other Python libraries has a decent set of APIs available for doing that. I can use that and make it part of my conductor workflow. And finally, allowing humans in the loop so that I can assign a task to a human, get an ETA and so forth. Where essentially, if I kind of look at a little bit more, right, essentially as a user, you make a query to an API endpoint that goes to a language model, goes to a vector database, but high level flow for putting humans in the loop with the AI. And this becomes very important when you are trying to productionize and you want to ensure that there's always a human, or for cases where you need humans in the loop, you can very easily and incorporate them in your application. All right. So where does Orkes fit into all of those things, right? So essentially, when you think about Orkes in conjunction with AWS, what Orkes allows you to do is, with Orkes conductor, essentially, it's a platform. So Orkes is not a foundational model. It's not a framework libraries like LangChain that allows you to work with a lot of data. But more importantly, it lets you take your own libraries, your language frameworks, your programming languages in choice. Allows you to integrate with things like AWS Bedrock, so that you can use different foundational models, and more importantly, allows you to run your generative AI applications in production, right? what we talked about earlier, right? What makes it harder today to go from POC to production is where our conductor was built, so that your POC is as good as production, and the moment your POC is ready, is functionally tested, is good to go, and you can put it in production knowing that, like, it will handle all the concerns that we talked about in terms of, what is it required to go to production with that. And where it helps you is, it allows you to kind of reduce the business complexity, because now you are not spending a lot of time trying to code up all those infrastructure concerns, right? So you can focus a lot more in terms of, delivering the business impact, and more importantly, in the end, what really matters the most, right? Which is you can go to market much faster. That is why conductor was created, and that's what it delivers. So what does it look like when it comes to building generative AI for applications or with conductor, right? So conductor again is a polyglot runtime for your distributed applications. It goes beyond generative AI, which means that, like, if you are into microservices orchestration, event-driven architecture, in the end, conductor provides the entire runtime for it. You can use the frameworks that you are already familiar with. So, if you are using Spring Boot for building out applications, you can use Spring Boot to, create conductor workflows and use them. You can write workers, which are essentially your tasks in Python, in Java, C#, Golang, TypeScript. And more importantly, it allows you to kind of put together asynchronous communication across the board. And what conductor essentially implements is durable executions, right? So once you create a workflow, the workflow is guaranteed to complete. Even if it is a long-running workflow, you don't have to worry about maintaining the state, maintaining the durability of it. It handles the underlying infrastructure failures, rate limits, and all of those things. And again, as I mentioned, right, like is a simple screenshot with how you handle essentially prompt management with AI. So, instead of kind of trying to kind of put your prompts in a template file, it allows you to safely incorporate those things and manage it with the right level of access control, governance, and everything that we talked about earlier. And again, Orkes is based on Conductor open source, something that we built and continue to maintain, which is a service orchestration platform originally built at Netflix. It's now supported by Orkes and a community of open source developer. So feel free to take a look at it if you want to try out and Conductor is kind of well adopted across the community, right? It has been out there for a while. If you go to the next slide, here are some of the existing users of Conductor, both at Orkes as well as open source, and you will see a lot of well-known names here that you might already be familiar with, are a customer or probably working for one. All right, so that's basically the end of it. If you have any questions, let us know. You have my and Ray's email here. So, if you have any follow-up questions, feel free to send an email to us. Happy to answer those things. We are in the marketplace. So, take a look at it. If you want to try it out, you can sign up for a free trial, and happy to work with you on those things.
Hey, Varun. I wanted to throw a couple things out there, as we're looking at this. I think it's important to point out from an AWS perspective, AWS provides the platform and the tools for our partners and our customers to build on, but not everybody has those development capabilities. And I think it just goes kind of understated how much Conductor is doing in the orchestration and the management that kind of removes that heavy development layer. So definitely worth checking out just how much work has been done under the hood, and it gives you such a nice easy GUI to work with there. But as I said, Orkes, we work together as part of the Amazon Partner Network, also known as the APN. And this is a program that Amazon runs to help its partners not only become enabled on the products, but we also help in supporting the business process, the go-to-market. And in an instance like this, where Orkes has put together this incredible tool, before it can hit the marketplace, they work with us, and we go through a technical validation, make sure that it's going to perform, and do what it says it does. We help them architect that in the best way possible. So just kind of like throwing that out there for thinking about how we engage with our partners and try to help them out. We also join our partners in trying to, we do webinars like this. We communicate with our internal organization so that our salespeople, our SAs all know what they have to offer, what Conductor can do. That way, other partners that may need not all partners have this orchestration capability, so we team partners together. We also help customers link up with our partners as well. So definitely, if you have any questions, feel free to ask, but go check out Conductor on Marketplace. I've got the link right here for you.
Awesome. Thanks, guys. I'm going to stop sharing really quick just so I can get access to, got a couple of Q&As, and Viren and Ray, I'll let you kind of decide. This first one is specifically around Conductor. So Viren, how can Conductor support WebSocket for LLM streaming responses?
Right. So the way it works today is, if you are using Conductor and, calling the Conductor APIs, you can have your API support WebSockets natively. We are in the process of kind of building that out, but it's not there yet. So that's something kind of in the roadmap. But there are ways to kind of make it happen. Happy to discuss offline on this one. Yeah,
for sure. And then another question from the same visitor. How can we support fan-out workflows? For example, let's say I have a video interface system, but the chunks need to be inferred in parallel.
So Conductor has a notion of a fork join, which basically does exactly what you are looking for, and it's pretty widely used. And as a matter of fact, it was originally built for the exact same use case, which was to process video chunks in parallel at Netflix. And so, what you would do is, either, your forks are kind of static in terms of, at definition time. But in case of video inference, is more likely not. So, you can have a dynamically generated forks. So, you take a video file, create, let's say, a chunk at every 5 minutes, or based on some time code markers. And then for every chunk, you do a fan out, and then all of this runs in parallel, and you wait until the end of it. So the fork join or dynamic fork is the answer to this question.
Awesome. Okay, it sounds like that's all the questions we had. Again, I'll be sending out a recording of this webinar, as well as a way to get in touch with some of our sales associates, as well as engineers as well, if there are any specific questions you have. As well as you can also join the Conductor Slack channel to join the community. We're very active in there, as many of our OSS and current users are, just in terms of if there are any questions you might have. Our community is pretty great at answering a lot of those questions. And then I think Viren mentioned it, but we do have a free trial. In addition to our listing at AWS Marketplace, we also have a free trial on our website as well too. So you can get access to Enterprise Conductor via Orkes for 14 days and get to test out some of the cool features that we've talked about today. So with that, I want to thank both Ray and Viren for this presentation today. Thank you guys for spending a few minutes with us at Orkes and AWS, and hope you guys have a great rest of your day.